Good. What's your example? Good. What is your example for the degree of monomial?
It was, we went from 3y to the third power, and then under it was 7x to the second power, y to the third power.
When you say under, like, am I dividing it?
Yeah,
Or?
no, under it, and then it went to the, because this is the monomial, and then it goes over the degree of it.
So that's 3y to the third.
And then it just went to 3.
Huh?
And then 3.
And 3. So is that your degree?
Yeah.
Okay, so the degree is 3. So which one are you taking? Are you taking this or that? Which one belongs to the degree? Because you got 2 3's there. The exponent is right, okay? So if I were you, guys, don't write 2 3's in an example. Let's just write 4 right there. Would that be okay? What do you have? 4y to the third. Then the degree would be what? 3, because that's the exponent. Okay? Polynomial. What did you write down, Diego? What is your definition of polynomial?
An expression consisting of variables and coefficients.
How many? Guys, polynomial means how many terms? More than?
2.
More than 2. So it has to be, because a monomial is 1. Would you guys agree with that? A binomial means how many? 2. Usually if you have 3 terms, we even have a word for that. What would we call a 3-term expression? Trinomial. So normally 1, 2, 3, we have exact name for each and every one of those. Anything over 3, we call it a polynomial. But technically poly just means many. So technically 2 could 2 equate as a polynomial. Yeah, so it's 3. Okay. Degree of a polynomial. Naomi, what did you write down?
The highest of the degrees of its monomials with non-zero coefficients.
Good job. Highest degree. That's the term. Okay. What is Sophia H, what is your definition of the polynomial function?
I said a function involving only non-integer powers.
Okay. Non-integer what?
Powers.
Okay. So polynomial, meaning that you're going to have, obviously the word polynomial, you're going to have many, okay, many terms. And the word function, the difference between a function and an expression is that a function has an equal. It's an equation. It's an equal sign, okay? And the degree of that has to be integers, okay? Standard form of a polynomial function. Slater, what did you write down? Good job, okay? So kids, start working on your homework. Pay attention, okay? If I ask you to write the polynomial function in standard form, that means you're putting it in degrees. Highest degree term first, second high degree term second, and so on and so forth. Now, these two are new, turning points and end behavior. Elena, what did you write down for turning point?
Point on the graph where graph changes from increasing to decreasing.
Good, I'm gonna make a sketch. So point on graph when graph changes from increase to decrease. Okay, for the sake of, okay, here we go. I want you to look at my made up example on turning point. How many turning point do you think this function has? Let's see. Is that one of them? Right here in the bottom? Good. 1, 2, 3, and 4. So class, turning points in essence are the minimum or the maximum. Okay. Now end behavior is related to this graph. Okay. So Karis, what did you write down for end behavior? So what does that mean?
Oh, what is going on at the end of each?
Okay, what's going on at the end of the graph? So it's talking about the y value. Okay, so let's use the same exact graph that we have sketched out for turning point. As x approaches positive infinity, that means I'm going right or left? Right. As I'm going to the right, what is the end behavior of this sketch out equation or function? What's the y? What's happening to the y value? It's going downward. Is it stopping at some location that we know? No. Because of the arrow, we know that it's going to keep going forever. So as x approaches positive infinity, y is going where? towards negative infinity. Okay, so that's an end behavior. And usually in end behavior, we're talking about both sides. Now, as x approaches negative infinity, what's happening to my y? Based on this sketch. Y is approaching what? Pause infinity. So the end behavior, it's just in its name where the ends are going to be at. Okay, so in a little bit, you're going to see, I'm going to ask you guys for the end behavior. You're going to see where's x going and where's y going. Okay, so those are the definitions. Example 1, y equals negative 4 plus 3x squared minus 6x to the third. A, write the polynomial function in standard form. How do we start? Lowest power first or highest power first? Highest power first. So here we go. Y equals, what is the term, hon, with the highest degree? Good. Negative 6x cubed. Jake, what's your next term?
3x squared.
Plus 3x squared. And final term would be Adam. Good job. Okay, so that's how we write it in standard form. Highest degree first. Name it based on the degree. Guys, what's the degree of this function? What's the degree of this function? 3, guys, because remember, we already wrote it in the order of degree. That's the degree. Because we only take the highest one. So this function has a degree of 3. So how do we name that? Is it a linear? By the way, what degree is linear? A linear equation. 1 or 0? Okay. Would you agree that the y equals 2x minus 5? Is that a linear equation? What degree is that? 1, class. This x has a 1 degree. It's a degree 1. Next equation that you study was the quadratic equation. What degree was that? 2. So if it has a degree of 2, we would call it quadratic. Now, this is a degree of 3. What do we call it? We studied this already. Cubic. So guys, name it, meaning that this is a cubic function. Next, name it based on the number of terms. Class, tell me how many terms you got. 3 terms. What is the name for an expression 3 terms? Monomial, binomial, trinomial. Trinomial, okay? So this is a trinomial because it has how many terms? 3. Tris. Tri. Okay. We have multiple functions that we are reviewing. Function number 1 is called constant function. We are going to graph it out. How do we graph out constant function? For this particular constant function, y is always at 2. This is why I said to grab a straight line. I mean straight edge. All right, so function number 1 is a constant function. We're going to graph the first 3, and then as you can see the next page, since I ran out of room, we have to answer all of this stuff, okay? Okay. How do we graph out linear function, which is the second graph here? Where do we start? At negative. Someone said start at negative 3, good. Mariana, what's the slope? Good. Go up 3 over 2. Do it a few times. Normally, I plot all of the dots that the grid allows. The more dots, the straighter line. Okay. Alyssa, what's the name of equation number 3? Good. So equation number 3 is your quadratic function here. And you guys just got done graphing that. Currently, that's in standard form. How do we graph that guy out? Uh-oh. You guys just... What would you need to graph out that standard form quadratic function? Vertexes, right. So I'm going to write ABC first. What's the A value of this equation? 1. B value. 2. C value. Good. Well, that's not H and K. Would you guys agree with that? To find the vertex is normally written in HK form. How do I get the H coordinate of your vertex? What's the formula? That's right. H is going to be negative B all over 2A. All right. What's your B value again? 2. Okay, so H equals negative 2 divided by 2 times, what's A value? 1. So H comes out to be a negative 1. How would you get the K value? Plug it in. All right. So F, oh, you already got it. All right, negative 1 equals negative 1 quantity square plus 2 times negative 1 minus 3. What's negative 1 quantity square, y'all? 1, okay. So that's going to give us 1 minus 2 minus 3. What's 1 minus 2? What's 1 minus 2? Negative 1 minus 3? Ah, okay. So your HK value, vertex, is negative 1 comma negative 4. Your A value is 1. So do we have any vertical stretches or compressions? No. So all we have to do is make the parent.
Good
Whoa.
morning, Oilers.
That scared me.
Christy.